By definition, activity is the number of decays per second, and is measured in a unit called Becquerels, named after Henry Becquerel. For an example, think about a beta emitter that gives out 200 beta particles in 40 seconds. So I need to find the number of decays per second. So all I need to do is divide 200 by 40. So the answer is 5 becquerels. Half-life is the average time it takes for the number of radioactive nuclei to halve. There's a second version of definition which says the average time it takes for the activity to halve. Now, just like a minute ago, we discussed what activity is, for the time it takes for that to halve. Let's look at a simple example. Say you have a sample of radioactive material with 72,000 atoms to start. Then after one half-life, this is the symbol for half-life, like T and a half like that, right? You can just write the word half-life if you want, that's okay. So the average time it takes for the number of radioactive nuclei to halve. Now let's say this half-life is 5 hours. So if you check in 5 hours, the number of radioactive atoms will be half of 72,000, which is 36,000. Now check it in another 5 hours, it will be half of 36,000, which is 18,000. Give it another 5 hours, it will be 9,000. Another 5 hours, 4,500, so on and so forth. Now here you can see how the activity changes with time on a graph. Now let's look at some of the numbers on this graph. You can see this is 800 here. So half-life is the time it takes for the activity or number of nuclei to halve. So what's half of 800? 400. Now you go to the right and you come down, and what's the time? It takes 2 hours. So I can see the half-life here is 2 hours. Now it works just the same way if you go from 400 to 200. Now let's see, 400 to 200, you go to the right, you come down, and here's the time, 4 hours. But remember, it started from 400. So we need to get it from 400 to 200. That's from this 2-hour time to the 4-hour. That's obviously 2 hours. The difference is 2 hours. This is the half-life of this particular element. Now, different elements have different half-life. Sometimes it can be less than a second. Sometimes it can be a couple of days, maybe 100 years, hundreds of years, thousands of years, or even millions of years. And you will be given those values in the exam if they ask a question based on this. And here's a question for you to try. You have a sample of 48,000 atoms. Half-life is 6 hours. Just complete the number of atoms left after each 6-hour period. When you're ready for the answer, press play. Now, one half-life will halve 48,000. So you get 24,000, 12,000, 6,000, and so on and so forth. Here you can see a slightly trickier question. If you want to give it a try, please pause the video and do so. And I will do the explanation right after that. Now in this one, the initial number of atoms is 600,000 and the half-life is 12 hours. Find the number of atoms left after 3 days. Now this is in hours, this is in days. Obviously 3 days is 3 times 24 is 72 hours. Now we need to see how many half-lives is that. So the number of half-lives is 72 divided by 12, which is 6. So this 600,000 should half 6 times.